Hello students, in today's session of NCERT Chapter Thermodynamics, very basic concepts on the topic of first law of thermodynamics, work done in different process, mere relation and other topics will be cleared through illustrations. In earlier session we have gone through thermal work done in cyclic process. In this case, illustration was taken from JEE main previous year questions, which you can review on YouTube channel sethiswiftlearn. In today's session, we are going to discuss what is CP, what is CV, what is law of equipartition of energy. If atomicity of gas is known. If atomicity of gas is known, Cp is known, Cv is known, gamma is known. Gamma is specific heat. This is known, this is known. Right? And what is isothermal process? What is adiabatic? What is isobaric and isochoric? In which case, none of the zeros, delta Q, delta U, delta W. In which case, none of it is zero. All are going to discuss in detail. It is requested to go through the complete session, being very important for 11th standard, JEE main, JEE advanced, CUET and NEET and other entrance examinations. Now let's start with the question and concepts. Question is, in isobaric process for an ideal monoatomic gas, if Q is 50 joule, then what will be the value of delta U and W? Concept applicable and solution. What is first law of thermodynamics? Is a statement of conservation of energy applied to any system in which energy transfer from or to the surrounding is considered. It states that heat given to the system is either used in doing action work or it increases the energy of the system or both. Mathematically, Q equal to delta U plus W. Sign convention is given. Means heat given to the system is positive, increase in internal energy is positive, work done by the system is positive. Again repeating, according to the law of conservation of energy, as first law of thermodynamics, Q equal to delta U plus W. Sign convention is give. Give means energy given to the system is positive, increase in internal energy is positive, work done by the system is by the system, increase in positive, otherwise sign will be negative. Right? This is this. In this case, Q equal to delta U plus delta W. In adiabatic process, Q equal to 0. In isochoric, delta U. In isothermal, delta U equal to 0. In isochoric, V equal to 0. But in case of isobaric, none of Q, delta U and W is 0. None of this is 0. Now, according to question, we have to find the nature of gas is monoatomic. Nature of gas is monoatomic. Q is 50 joule. Now, in this case, they are related delta Q Q लिखो delta U plus W. Delta Q equal to delta U plus W. So heat given to that is Cp NCP delta T equal to NCV delta T plus P delta V and for 1 mole N equal to 1. So on simplification, delta Q is to delta U is to W comes out to be N कट जाएगा, Cp is to Cv is to P delta V is equal to लिख सकते हैं इसको R delta T. R delta T means Q is to delta U is to W are in the ratio of Cp is to Cv is to R delta T. Only R delta T तो कट गया, R delta T कट गया, Cp is to Cv is to R. This is the ratio divided in these ratios, right? Where this is the molar specific heat at constant pressure. This is a molar specific constant volume. This is the universal gas constant. Universal gas constant. Universal gas constant. Now, if we know atomicity of the gas, if we know the atomicity of gas, if we know the atomicity of gas, in this case, yes, and degree of freedom is 1. Degree of freedom is monoatomic. 3. Degree of freedom is 3. What is that? Gamma equal to होता है 1 plus 2 by F, 356. F is the degree of freedom. मोनोएटॉमिक के लिए 3 है, डाइएटॉमिक के लिए 3 है, और 6 है ट्राइएटॉमिक के लिए in general, right? This is the specific heat ratio. The specific heat ratio. Now, relation between Cp and Cv is Maer's relation. Maer's relation. That is Cp minus Cv equal to R. This is the relation between Cp and Cv. Now, to find the values. Now, to find Cp and Cv as atomicity is known, means that is monoatomic. Degree of freedom is F is 3. 1 mole N equal to 1. Now according to law of equipartition of energy. What does it say? This is in case of an ideal gas, it distributes its internal energy equally in all degrees of freedom. The internal energy of the N molecule gas is given by U equal to N by 2 FRT. It is just like an ideal father. Distribute its property equally in all children. In the similar fashion like this, right? Now, U equal to F by 2 nRT. F is 3, N is 1, then 3 by 2 RT. So this is Cp. Cp is 3 by 2 R. Using Mayer's relation, Cp minus Cv equal to R. So Cp equal to R plus 3 by 2 R, that is 5 by 2 R. Cp is known, Cv is known, R is known. Therefore, Q is to delta U is to W is to Cp, Cv is to R. Right? Question was oral answer can be given, but I was supposed to clear the very basic concepts applicable in this question. Cp is 5 by 2 R is to Cv, 3 by 2 R is to R. So this relation comes out to be 5 is to 3 is to 2. Right? Now, according to question, Q is 50 joule. So delta U will be equal to 3 by 10 into 50, that is 5. That will come out to be 50 joule. That is 50 joule. That is 50 joule. Five is to 3 is to 2 divided. 5 ratio is 3 ratio is 2 is. So this comes out to be, delta U comes out to be 3 upon 5 into 50. That is done 30 joule. And W comes out to be 2 upon 5 into 50. That is 20 joule. तो इनका रेशियो चेक कर लीजिए 50 is to 30 is to 20. This comes out to 5 is to 3 is to 2. So our answer is delta U equal to 30 joule and delta U equal to W equal to 20 joule. This is the answer. Right? Next question. Question is, at 27 degrees centigrade, 2 moles of an ideal gas occupy volume V. The gas expands adiabatically to volume 2V. Calculate final temperature of the gas, change in its internal energy, work done by the gas during the process. You have to find 3 parts. Concept, applicable and solution. You know first of the thermodynamics, Q equal to delta U plus W. Sign convention I have discussed in the earlier question. Heat given to the system is positive, increase in internal energy is positive, work done by the system is positive. Now in the given case, it is given adiabatic. In adiabatic process, these are the concepts applicable. Work done adiabatic N R Ti minus Ti from gamma minus 1. One is PV equation, PV equal to gamma. This is very standard equation. Gamma is the specific heat ratio. Specific heat ratio. Specific heat ratio. If atomicity is known, Cp is known, Cv is known, Cp is known, Cv is known, gamma is known. According to law of equipartition of energy, that is U equal to 1 by 2 NFRT. NFRT. So multiplier of this is Cv and Mayer's relation Cp minus Cv equal to R. We can find R equal to Cp. Cv. This is Cv. This is Cp. Right? And gamma equal to 1 plus 2 by F 356. 3 is more for monoatomic gas, 5 is for diatomic gas, 6 is for triatomic gas. Gamma is known, gamma equal to होता है Cp upon Cv. Means if we know the atomicity, we know the specific heat at constant pressure, molar specific heat at constant volume, we know the specific heat ratio, right? And also these equations are very simple. In this case, if PV gamma equal to constant, we have to find this equation, PV gamma. To use the relation PV equal to RT. If you know that, then you put that directly, otherwise PV gamma should be known to you. P equal to R, RT. So we have to find in terms of PV, the eliminating P, RT upon V gamma equal to constant. Now, TV gamma minus 1 equal to R is also constant, that is constant. ये relation आ गया. This one, TV gamma. Now, according to question, we have to use this relation. Now, let's start with the question. Now, according to question, N equal to 2, nature of gas is monoatomic. Nature of gas is monoatomic. First part is we have to find final temperature of the gas. T1 is 27 plus 273, that is 300 K. V1 is V, V2 is 2V. We have to find T2. Now we should know the gamma. Gamma equal to क्या होता है? 1 plus F by 2 by F, 356. This is a monoatomic gas. 5 for di, 6 for tri. That comes from 1 plus 2 by 3. That is 5 by 3. That comes out to 5 by 1 plus 2 by 3, 5 by 3. Gamma is 5 by 3. Now, according to, as the process is adiabatic, Q equal to 0, neither heat will be given nor heat will be taken. According to first law of thermodynamics, Q equal to delta U plus delta W. In the second part, you have to find the energy increase or decrease, then you have to find this. To find this is 0, if we know this, then this is also known to us. Now, final temperature. Final temperature, you have to use T1 V1 gamma minus 1 equal to T2 V2 gamma minus 1. This comes out to be, we have to find T2. T2 equal to T1 V1 over V2 gamma minus 1, that is T1 300 V1 1 by 2, 5 by 3 minus 1, 300 upon 1 by 2 की power 2 by 3. On simplification, this comes out to be 189 Kelvin. 189 Kelvin. This is the final A part answer. This is the A part answer. Right? This is the A part. Change in internal energy. Change in internal energy will be delta U will be 1 by 2 N F R delta T. This is CV. Means 1 by 2. This is 1 by 2. 1 by 2 and N 2 F degree of freedom is 3 R into delta T. So this comes out to 1 by 2 into 2 into 3 R into 8.31 into delta T. Final temperature minus initial temperature 189 minus 300. Okay. On simplification, this comes out to be minus 2767.23 joule. 2763 joule means there is decrease in internal energy. Decrease in internal energy. Now to find work done, Q equal to delta U plus W. This is 0 as the process is adiabatic. This is minus 2727 point something 0.23 plus W. Therefore, W comes out to be 2727.23 joule. This is a positive. Work done by the system is positive. Sign convention is give. Heat given to the system is positive. Increase in is positive. Work done by the system is positive. It comes out to positive. This is the answer of C part, right?
Before start of the next question, I would like to say that these concept clearing videos for the purpose of 11th standard, 12th standard, state boards, CBSE board, JEE main, JEE advanced, NEET, CUET, and other entrance examination. These concept clearing videos are very helpful and useful, which you can review on YouTube channel sethiswiftlearn. In addition to this, I would like to say that these papers, complete video of discussions are available on sethiswiftlearn YouTube channel, which you can review on sethiswiftlearn. In addition to this, further, these papers, detailed solution with additional information available on website sethiswiftlearn.com. You can visit the site and have the solution. इसी के साथ साथ मैं रिक्वेस्ट करना चाहूँगा कि अगर अभी तक आपने YouTube चैनल sethiswiftlearn सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद योर colleagues and friends. Now let's start with the question.
Question is, 1 mole of a monoatomic gas is taken through a cycle shown in the figure. A to B, B to C, C to D, D to A. A to B is adiabatic expansion. B to C is cooling at constant volume. C to D, again adiabatic compression. And D to A is adiabatic heating at constant volume. The pressure and temperature of A, B, etc. denoted with PA, TA, PB, TB, etc. respectively. Given है हमें T equal to 1000 के PB and P are related, PC 1/3P in the process. Calculate work done by the gas in the process A to B. Concept applicable in solution. Adiabatic, it is the case of adiabatic expansion. In adiabatic expansion, work done is given by NR TF, Ti minus TF, initial temperature, final temperature. That is NR Ti, Ta minus Tb upon gamma minus 1. Here N is given to you 1 mole. N is 1 mole, R की value 8.31 SI unit. T given है 1000 Kelvin. Tb we have to find it out. Relation between pressure and temperature is given to. Relation between pressure and temperature is given to. Temperature and pressure are related. Means we can use this equation to find Tb. P1 1 minus gamma, T1 equal to P2 1 minus gamma, P2 gamma. That is TB gamma, PB gamma, 1 minus gamma equal to T1 TA gamma P1 PA 1 minus gamma. We have to find it out. TB will come out to be TA PA upon PB into E upon square root of 1 minus gamma upon gamma, 1 minus gamma upon gamma. Or you can say ये आ जाएगा साइन नेगेटिव आएगा, तो दिस कम्स आउट टू बी TA PB upon PA, that comes out to 1 minus 1 upon gamma. Now as atomicity is known, N equal to given the monoatomic gas is there. So gamma equal to होता है 1 plus 2 by F356. Degree of freedom is 3 for monoatomic, di for 5, 6 for diatomic. So gamma equal to 1 plus 2 by 3, that is 5 by 3. Gamma is known to you. This is 1000 into PB. PB PA में relation given है. PB upon PA 2 by 3. PB upon PA 2 by 3. 2 by 3. 2 by 3. 1 minus 1 upon gamma. Gamma comes out to 5 by 3. So 3 by 5. On simplification, this comes out to be 850 Kelvin. 850 Kelvin TB. Now, substituting the value here, 1 into 8.31 into TA 1000 minus 850 divided by 5 by 3 minus 1. On simplification, this comes out to be, this will come out to be WAB 1869.51 joule. That is WAB. Complete procedure has been prescribed. Now, second part. Now, to start second part. Second part is the heat lost by the gas in the process B2C. Heat lost by the process in B2C. Heat lost by in the process B2C. B2C is isochoric. Volume is constant. Volume is constant means W will be equal to 0 as equal to P delta V. Delta Q equal to delta U plus W. So therefore Q will be equal to delta U. Delta U will be equal to N, delta U equal to given by N by 2 FRT. So this is degree of freedom in monoatomic gas 3 by 2 R. This is CV. N into 3 by 2 R into temperature. Temperature TB minus TC. So N is 1 mole or 2 mole? N is 1 mole of a gas B2C. N is 1 mole into 3 by 2 R. R is 8.31 into TB. TB is 850. 850 minus TC. How to find TC? TC is R. Now in this case, as you know, PV equal to RT, ideal gas equation. This is constant, the P proportional to T. That is PB upon PC equal to TB upon TC. We have to find TC. TC would be equal to TB into PC upon TB. TB is 850 into PC. To find TC, how to find TC? This is given to you. Everything PC is 1 by 3 PA. 1 by 3 PA upon 1 by 3 PA upon 2 by 3 PA. 2 by 3 PA. That is 850 divided by 2. That is 425 Kelvin. PA cancel हो जाएगा 1 by 2 बचा. That is TC. TC calculate कर दिया from the given information. Therefore, Q comes out to be 3 by 2 into 8.31 into 850 minus 420. Final temperature minus initial temperature. After ये लिखेंगे TC minus TB. TC minus TB. तो ये प्लस हो जाएगा, ये माइनस हो जाएगा. तो माइनस प्लस 425. So on simplification, this comes out to be 5297. 5297 point something joule. Means negative sign indicates heat is lost by the system. Heat given to the system positive, taken out, heat is lost. So this is the answer for part 2. Right?
Now, I would like to request, if you are new to my YouTube channel, sethiswiftlearn, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you. धन्यवाद, बहुत बहुत धन्यवाद जी, बहुत बहुत धन्यवाद.